I set off the alarm. Future reference, the response time is about 15 minutes, so you've got some time. Where was I up to? Yes, minimum, maximum. So now we need to check 4 points. We need to check -4, -3, a third, and 1. And each of those points we're going to put into the original function, and that will give us our heights, basically. We're expecting this to be the lowest and this to be the highest, but it may work out, because of the nature of the curve, that actually one of these wins out for highest or lowest and is therefore the max or min. Now, you're all very capable of subbing 4 numbers into a cubic. Make sure it is the cubic though. So I'm not going to make you sit there and watch me struggle with mental arithmetic, but that will be how you find the max or min. And when you're asked to find a max or min, you're expected to give not just an x coordinate, but a y also. So you're after a point. Alright, so now we're going to go through the video solutions, the 3C. Feel free to switch off here, have a go at the 3C questions. If you get stuck, look back at this video and fast forward to the point where I write, 3C question 2A if you're stuck there, or 6B if you're stuck there on the board. This isn't going to be edited, so you guys just get to watch me erase the board again and again. Alright, question 1. So we're doing 3C. Question 1. Now, question 1 is very similar to our example. Find and classify the stationary points A and B. Find f-x and draw a sign diagram. Find the coordinates A and B. Right, B is a local minimum. A is a local minimum. B is a local maximum. Not sure if you guys can see me. Right, let's find f-x. F-x is going to be minus 3x squared plus 6x plus 9. And we want to draw a sign diagram, so we set it equal to 0. I would then factor out minus 3. 2x minus 3. Now, the reason we factor out minus 3, to get that coefficient of 1, it's coefficient of 1, we have sum and product. Sum and product looks like this. Things that multiply to -3 and add to -2 are x take 3, x plus 1. Therefore our solutions are x equals 3 and minus 1. And then if we're looking at a sign diagram, minus 1. We sub into the derivative. Frankly, I would sub into the factorized version just because it's much nicer. So if we sub in, say, minus 2 into here is minus 5, negative, 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 negative. 3 negatives makes that a negative. Sub in here, 0, negative, negative, positive, so positive. Sub in here, say 4. Positive, positive, negative is negative. Now, you were told already that this is A and this is B, so we found the points A and B. And then you can tell that this is a max and a min. Min, max. And you would sub these and these guys, get subbed into there to find the coordinates. Be careful when you're substituting a negative. It belongs in a brackets where x squared is because it'll come out as positive 1. So minus 3 times positive 1. Alright, not too bad. I think I've actually got more space here. Next question. I skipped question 2 because question 2 is exactly like question 1. We're going to do question 3. And I'm only going to do a couple of them. Question 3 is very quadratic heavy. The most challenging parts of this topic is the trig, so we'll just do a couple of quadratic-y ones. For each function, find and classify any stationary points and hence sketch its graph. Alright, let's go for the more difficult ones straight away. if we're looking at f of x is equal to x squared take 4x plus 5 to the half, we want to find its first derivative, create a sign diagram. So f dash x is equal to a half bracket x squared minus 4x plus 5 to the minus a half. And we're setting that equal to 0. So 0 equals 1 over 2 root x squared minus 4x plus 5. Interesting. So this is a common sort of trap. It should be noted in the back of your mind somewhere that square root of any function of x, so square root of f of x, will always give me a positive value. So 1 over 2, this, doesn't matter what's under there, is always going to be positive. So our sign diagram is just going to be one giant plus. It's going to be purely positive. Now, finally classify any stationary points. That means it has no stationary points, which seems rather odd. Hence, sketch its graph. Well, there are no stationary points, but it is still possible to experience a sign change if down here asymptotes. So we're going to look at, I guess, the original function. No, we're not. It's this. And then to sketch it, what's it going to be like? It's going to be like one of these, isn't it? I've summoned a few x values to find the point. But yeah, so D is a hard one because there are no stationary points at all. It is purely positive, purely increasing. And that kind of makes sense. Oh no, that's the sketch of the derivative. Square roots do this. That's a square root. Alright, let me find myself some space. Tell you what, talking to an empty room is weird. Must be how influencers feel. I'm going to go through my skincare routine. Alright, let's do 3e. If we have f of x is equal to x squared over x take 1, we should note to ourselves that immediately this implies that x is not equal to 1. Alright, f dash x. In order to find f dash x, I would let u equal x squared, v equal x take 1, u dash equals 2x, v dash equals 1. F dash x equals u dash v minus v dash u over v squared. This is going to take a little tidying. On the top, 2x squared take 2x minus x squared will be 1 lot of x squared take 2x. When you're doing these, don't rush to expand. It is tempting to expand this straight away, but I think we can do something a little fancier first. We can consider this as x bracket. Oh, we can't really x take 2. No, we are just going to leave it there. It doesn't need to expand. Alright, from here we're looking for when is that a solution? So when is it equal to 0? If we have x squared take 2x on x take 1 squared, the only way it can equal 0 is if the top is equal to 0. So, now that's what we're trying to solve, which means that we can do x bracket x take 2 equals 0. Our solution therefore is either x equals 0 or x equals 2. F dash x for There it is, 2, 0. Now we sub in, so we're going to sub in values below 0, so minus 1, and you're going to sub into the derivative, so probably here. Careful not to sub in here, sub in here. So if I'm subbing in minus 1, 1 plus 2, that's positive, and the bottom is always positive. Anything squared will always be positive. So that 4 at the top gives us the sign. If I sub in 1, meaning positive 1, 1 minus 2 is negative, on a positive is negative, and then if I sub in 3, 9 minus 6 is positive. So that we have a local max here and a min there. So, in order to sketch, now I'm not going to go through it in the interest of time because the thing will run out of batteries, but what that means is we sub in 0 to the original function. If I sub in 0 to there, what that's going to give me is 0 on negative 1, which is just 0. So there will be a max here at 0, 0. And if I sub in 2 to the original function, it will give me a minimum. So if I sub in 2, it will be 4 on 1. Not what I was expecting. Awkward. 4 on 1. It's 4. Which leads me to really want to check my math. Because that doesn't feel like a minimum if that's my maximum. So where did I go wrong? 0 and 2 work. I must have subbed it in wrong. If I sub in minus 1, definitely positive. If I sub in 1, definitely negative. Unless I messed up my derivative. 2x squared minus 2x. Take an x squared. 1x squared minus 2x. Alright, go to the next step back. U dash b take b dash u. I cannot for the life of me find where I messed up. Oh well, write a comment. You guys can comment on the YouTube videos. Hopefully you'll have spotted the error. The process should have been right. Differentiate. Set it equal to 0, solve, put in the derivative, sides. Alright. Do 4, shall we? Question 4. We'll do 8. X e to the minus x. Alright. Classify nature in the stationary points. Differentiate, sign diagram, sub in. For dy dx is u dash v plus, but now it becomes minus, v dash u. We want to set this equal to 0. Almost always with these e1s we're going to have a common factor, and it's an excellent idea to remove that. E to the minus x, bracket, 1 take x. Therefore, what this implies is that x is equal to 1. Alright, then we do that on a sign diagram. For f dash dash x, 1. Then we sub in. Sub in here or there. I would pick 0 because it's only within our domain. If we sub in 0, we get 1 times 1, it's positive. If we sub in 2, this is always positive. E to the power of n always gives a positive, so that's positive times negative. It's a negative. That means the graph is going up, down. There is a local max when x is 1, and their coordinate therefore is 1 e to the minus 1 from here. So that will be the local max point. We'll do another over here. From, let's do 4c, which starts off with y equals e to the x on x. Alright, so we did differentiate. U equals e to the x, v equals x, u dash is e to the x, v dash is 1. U dash v, x e to the x minus v dash u over x squared. That is now dy dx. Ooh, that's a weird one. We want to set it equal to 0. If we're setting this equal to 0, the solutions never come from the denominator, so we're really only interested in the numerator. And once again, we've got a common factor, so we're going to factorize it out. So it's really looking at where does e to the x take 1, equals 0. Again, x is 1. So what we're looking at here is a sign diagram for f dash x of x, where x is 1. And we want either side of that. The denominator here always returns a positive. So it's really this numerator, which is this, that gives us the solution. If we're entering 0 in here, that's positive, that's negative, so it'll be negative. If we're entering 2 in here, positive, positive, it'll be positive. What that implies is there is a min at the point 1, e. The reason it's just e is because it's e to the 1 on 1, which we've written as e, and that would be the local minimum. Alright, there is 2 from question 4. Hopefully that gives you enough to go by. Quick battery check. I'm halfway through this thing's battery already. Alright, question 5. Question 5 is y equals e to the ax over bx with a stationary point at a third e on 2. Find a and b. Alright, if we're after a and b, we want 2 equations. Very similar to what we saw in the first topic. One equation comes from the fact that this point is true. The other equation comes from the fact that when x is a third, the first derivative is equal to 0. So let's just do the first point is true thing, meaning we can sub this in for our x and y and make this right. So that means e on 2 is equal to, when x is a third, e to the a on 3 over a third b, b on 3. It's not pretty, but we're just going to leave that there for now. I don't want to rearrange it in particular form until I see how the next equation comes out. If I see the next equation comes out in a particular form, I'll start manipulating that one. Alright, we're after dy dx, so we're going to go u and v. U is e to the ax v is bx, u dash is a e to the ax, v dash is just b. Therefore dy dx is u dash v, which is a b x e to the ax. By convention you put the e on the end and the rest in alphabetical order. Take b e to the ax over bx squared. And we know that this is equal to 0 when x is 1/3. This whole thing is equal to 0 when x is 1/3. What that really is telling us is the numerator is equal to 0 when x is 1/3. I don't think we really need to bother with this bit just yet. So what that is saying is that ab a third e to the a on 3 minus b e to the a on 3 is equal to 0. That comes from the fact that it's a stationary point when x is a third. Alright, quick step back. I think it's very possible for us to replace this e a to the 3 with something. So, traditionally we get a or b by itself, and we probably could here, but I think it's actually very easy for me to get this e a to the 3 on its own. Not sure if that entirely helps me, but it feels good, so let's go with that. To do that, I'm going to multiply both sides by this. So if I multiply both sides by this, it becomes eb on 6 equals e a to the a 1/3. The reason I'm doing that, or the reason I got that, is e on 2 times b on 3 gives me that eb on 6. So I can say that e to the a on 3 is eb on 6. Alright, let's see if that helps here. A, b third, eb on 6 minus b, eb on 6. Yeah, I mean, we've still got the issue where there's an a and a b mixed in together. It's not a complete end of the world, but it's not great. That's right. You guys get to watch problem solving in action now. It's probably not very riveting for you. These can't combine because the a here and the b means they're not like terms. I could factor it out. I could factor b out. New plan. Let's go back to, I guess, what should have been the old plan, is get one of the letters by themselves. One of the letters by themselves, I mean, I wouldn't cross this out yet, but like, in your head, it's not so useful. So, we're not going to cross it out, because we might use it later, but it's not useful right now. Instead, what I'm going to do is take this and get b by itself. So if I multiply both sides by 6, eb equals 6e a third, and then if I divide both sides by e. Now, dividing both sides by e is like removing 1 power of e, so b equals 6e a to the 3 take 1. Or we could write it as over e. That might actually be nice. Take one at the top, e down there, same thing. Alright, we're going to sub that into here. So let's take that up there. A, and then instead of b, it's 6e to the a on 3 on e times e to the a on 3 minus 6e to the a on 3 on e equals 0. Ooh. E to the a on 3. So that's the b, and that's that one. Alright, I mean, we're looking at something that's quite common here. I want to factor out this entire thing and this entire thing because it's the same. And at this point, I am going to bring in the e to make it a -1 and the e to make it a -1. Because really, when you have bases which multiply, you add the powers. So it's going to be 2a on 3 minus 1, 2a on 3 minus 1. So really this is 6e to the 2a on 3 minus 1 bracket a, because that's the only thing left, minus 1 equals 0. Now, that was the only option I can see. The reason I was aiming for factorization is because that gives us our solution. Our solution is a equals 1. I haven't read the back of the book, so I really hope this is the actual solution. But it looks good. A is 1. Alright, if A is 1, then B, we can get by putting here. B is 6. That's a third minus 1, so 6e to the minus 2 on 3. Doesn't sound as elegant as it should be. But that would be our two answers. Alright, there's A and B. I still feel like this should have worked much nicer than the other way. Alright, running out of batteries, gotta move on. 7. Alright, question 7. Let's jump into 7b, shall we? Q7b. If f of x is cos 2x, and we're only interested in the period from 0 to 2 pi. And that's important, because otherwise we're finding lots and lots of mids or maximums. So, first derivative, f dash x is minus 2 sine 2x, and you're looking for where that equals 0. Minus 2 sine 2x equals 0. At this point, in fact for this entire thing, you guys should be having a unit circle on hand, or in your head, probably better than me, remembering that now we're looking really, 2 times what gives us 0. Sine is 0 here and here, which is 0 and pi. So, what we're looking at here is when 2x equals 0 or pi. Now, note, that's only one rotation. How you account for this is up to you a little bit. The fancy way to account for this is plus 2k pi. What that means is that every time we go around the circle, we're finding another solution. Methods doesn't tend to be fussed too much with this fanciness here. The examiners aren't being mean about losing marks for it. However, here, it is important to recognize that you can get more than 2 solutions. So this implies one loop around the circle. but really, this is the domain for x. X goes between 0 and 2 pi. I would be writing somewhere that, therefore, 2x is a member of 0 to 4 pi. If x is between 0 and 2 pi, when you double it, that bit in there, the bit in there can go between 0 and 4 pi. So really, our solutions in this case are not just 0 pi, they are 2 pi, they are 3 pi, and technically, because 4 pi is included, we're back here at 4 pi. So be careful that this domain restriction doesn't just restrict you to one loop around the circle, it just restricts the boundaries for x. If this was 3, really that's implying 3 laps around the circle. If it was a half, then we're restricted to 2 solutions because it's just this and this. But really, these are our solutions. So our sign diagram goes between 0 and 2 pi. Actually, we haven't even solved it yet. If 2x is 0 pi, pi on 2, pi on 3, 2 pi, 3 pi, 4 pi. Therefore, x is you basically divide both of these by 2. X is still 0, or pi on 2, or pi, or 3 pi on 2, or 2 pi. What that is saying is if you sub x equals pi on 2 into this equation, you get 2 times pi on 2, which is your pi. If you sub pi in here, 2 times pi is your 2 pi. This is your set of solutions. So we'll do a few more of these trig ones, battery permitting. Battery check. Still good. Here, and you take the bit that's important, find its solutions. Then, in this case, we divide by 2 to get the x on its own, and divide all the solutions by 2 as well. And that gives us our full range of solutions. So our sign diagram, don't know why I bothered with the ruler. You guys don't care that much, do you? Actually, we're going to cut it there at 0, and we're cutting it here at 2 pi. And we are looking at a solution of 0, which is there, pi on 2, pi, 3 pi on 2, 2 pi. Terrible spacing. Position and nature of the stationary points. So we will then need to sub in values here. We sub in a value here. What that looks like is we're subbing a value between 0 and pi on 2 in here. When we double it, we're still over here, meaning we're still positive. Or you can sub it into actually into here. If we're between pi on 2 and pi, meaning we're between pi on 2 and pi, when we double it, if we say like here, that's like a third of the way around the circle. Doubling it is now 2/3 of the way around. So like here, sign is now negative. And because it's sign diagram or a sign graph, you can kind of assume it does that because it will, because it oscillates. So this is max, min, max. That'll be a min, and this will be a min as well. Alright, we'll do a few more trig ones. Alright, really we're going to think about this as an f of x squared, which when differentiates becomes 2 f of x times f dash x. So therefore our f dash x is 2 sine x multiplied by cos x. And we're looking for where that equals 0. And this is going to get hectic. The reason it's getting hectic is because really this is in the form of AB equals 0. Meaning every time there's a solution for either of them, meaning either time either of them equals 0, we're going to get a 0 overall. So really what we're looking for here is we're looking for when does sine x equal 0 and when does cos x equal 0. Sine x equals 0 in our domain of 0 to 2 pi 3 times. 0, pi, 2 pi. Cos x equals 0 at pi on 2, the top of the circle, and 3 pi on 2, the bottom of the circle. So, unit circle on hand, getting good at these. No, we're coming here, 0, don't want the arrow, we want 4 pi, sorry, 2 pi. 2 pi. Then we plot in these points. 0, pi on 2, pi, 3 pi on 2, 2 pi. 0 is already in there, so pi on 2. I should have just left the last one, shouldn't I? What do we get? Pi. 3 pi on 2, 2 pi. Alright, now when we substitute in, it's probably helpful to remember that horrible mnemonic. All silly turtles crawl. There are less polite versions. Here, all them positive, sine positive, tan positive, cos positive. So between 0 and pi on 2, they're all positive. So we've really got 2 times positive, so it's positive. Here, only sine is positive. That's in this one here, so negative. Then between pi and 3 pi on 2, pi, 3 pi on 2, only tan is positive. Interesting here, that means that cos and sine are negative. Negative, negative, and positive make it positive. Then over here, only cos, you can probably guess it's going to be negative. And that will give you your position of each turning point, max, min, max. Alright. Kind of hoping one of the ones in here makes us use the tan trick. I think E and F might both use the tan trick. 7E. If we are looking at f of x equals, what, cos x take sine x? F dash x is, that becomes minus sine. So I'm actually going to put it here, minus sine x. It's a terrible x. You guys can probably see where this is going. Minus sine x, and that becomes positive cos x. Except it's a negative already, so it's negative cos x. I don't know why I switched that place. That becomes minus sine, that's already negative, but doesn't change, so it becomes cos. Now I set it equal to 0. 0 equals minus cos x minus sine x. Alright, here it's too hard to try and pick solutions off the top of our heads. Instead, what we're aiming for is to get it into a single form, and that form will be tan. I would start by adding sine x to both sides. And then I would divide by cos. It's worth noting at this point that tan x is sine x on cos x, and this is the only, or this in the Pythagorean one with the x squared and y squared thing, are the only one that you really have to know and be comfortable using. When that divides out, you get tan x minus cos x on cos x is minus 1. So then we're thinking about when does tan equal negative 1? And on your unit circle, you probably have little coordinate points with your cos and your sine. And at this point, it's worth going around to write in the tan of each of those key ones. So you should know tan of pi on 6, tan of pi on 4, tan of pi on 3, and so on. I happen to know, for example, that tan of pi on 4 is positive 1. Here, tan of, well, the critical angle there is pi on 4. So what's that? 3 pi on 4? 3 pi on 4 is negative 1. There's one of our solutions, and the other solution's down here, which is 7 pi on 4. And there's also another, a minus 1 there. So our two solutions here are 3 pi on 4, because it equals minus 1 at that point, and 7 pi on 4, because it equals minus 1 at that point. And this method of solving, dividing out to create a tan, and then having some value over here for the tan, is very common. So in a good unit circle, you should have not just the sine and cos values, but the tan ones as well. So then our x is 3 pi on 4, and 7 pi on 4. And you can probably go from there. What you're going to do is you're going to sub this in, each of them, into here. No. What am I talking about? We want a sine diagram. Don't sub them in. If you sub them into the original one, you'll get the location, but we just want whether they're maxes or mins at the moment. So we have 3 pi on 4, which means 0 and 2 pi. One day I'll stop doing it. 3 pi on 4. And 7 pi on 4. If we sub in between, I'll pick nice easy values to sub in between. For example, if I was going to sub in here, I'd pick pi on 2. Pi on 2, cos is 0, so it disappears altogether. Sine is positive 1, so the whole thing is negative 1. Then subbing into here, between 3 pi on 4 and 7 pi on 4, there's a whole bunch of options, but one of them is pi. I would sub into pi. If I sub pi into here, cos of pi is minus 1. The minus and minus 1 is positive. Minus nothing, it's going to be positive. Probably guess where this one's going. What I would sub in is I would sub in 2 pi. 2 pi is in the domain still, just. So if we sub in 2 pi, that's cos is positive 1, but it makes it negative, so it's negative. Alright. We will do f, one more. Battery check. Oh, one piece of battery left. We're not doing F because we're going to run out of batteries. We're going to move on. Question 8. Y equals 4e to the minus x sine x. Alright. We want to show it has a local max when x is pi on 4. So, sine diagram, u equals 4e to the minus x, v equals sine x. U dash is minus 4e to the minus x. V dash is cos x. dy dx is u dash v minus 4e to the minus x sine x plus v dash u 4e to the minus x cos x. And we want that to equal 0. So if I was going to equal that to 0, I would factor out the biggest common factor. So 0 equals 4e to the minus x, bracket minus sine x plus cos x. Now, this can never be 0. E to the power of anything is positive. That's positive. This is where our solution will come from. So we're looking for when minus sine x plus cos x is 0. I'm going to add sine to both sides. Then I'm going to divide by cos. And now I'm looking for when tan x equals 1. Tan x equals 1 here at pi on 4 and here at 5 pi on 4. So we're halfway there. We've got one of our solutions, pi on 4. Now we're trying to find the sine diagram. So and here's a little hack. The markers don't actually check you've substituted in. In maths, you shouldn't take shortcuts, but they've told us there's a local maximum here. So frankly, you can kind of do that, can't you? Because they've told you that. You're showing working to show that it's true. That's your working, your plus and your minus. They're not actually going to want if you check it. I would put it out here. I would substitute 1 out here. So out there we are going to do, what's that, 3 pi on 2. If we do 3 pi on 2, that bit's always positive. Here, sine is minus 1, so minus and minus 1 becomes positive, and that's 0, so it's positive and a positive. This is a positive as well. But in the interest of time saving, that's the only one that we actually had to substitute for because they told us this. And then we would say, after this, therefore there is a local max at pi on 4. Alright, question 9. Still some battery. It's really a challenge. Is the battery going to run out first, or will it be my voice or my brain? Maybe the battery. Q9. Alright. There is a function, f of t, yuck, at e to the bt squared has a max at 2, 1. Alright. Note, max, this also implies that f dash 2 equals 0. So that's one equation, second equation. Let's do this first equation first. Basically means that if we put in 2, we're getting it at 1. So 1 equals 2a e to the 4b. Not too bad, that's our first equation. Now let's differentiate this. If we're differentiating this, u is at, v is e to the bt squared. U is a, v dash is 2bt e to the bt squared. F dash t is u dash v plus v dash u 2ab squared e to the bt squared. Excuse my t's. This is equal to 0 when t is 2. T is 2, that's 4. So therefore this is 8 ab e. Pretty sure that was up high, wasn't it? Alright. Now, ideas, people. Ideas. I would suggest that getting an A on its own here is very easy. So we're going to do that. Let's get this A on its own. So A from here is equal to 1 over 2A to the 4B. That's not particularly nice, but I feel like it's actually going to work out kind of nicely here. 0 equals 1 over 2, did I say A? I meant E. E to the 4B, bracket E to the 4B, plus 8 lots of 1 over E to the 4B, B, E to the 4B. Oh, that's good stuff. Stuff because that goes and that goes. And what that leaves me is 0 equals a half plus 8b. Really that easy? I mean, I say really that easy, but I'll probably screw it up somehow, haven't I? Minus a half equals 8b. B equals minus 1 on 16. If B is minus 1 on 16, A is 1 over 2E to the minus a quarter. 4 times 16th is 4/16 quarter, which I guess could be written as E to the positive quarter on 2. Alright. Alright. Prove ln x on x is less than or equal to 1 on e for x is greater than 0. What this is really saying is, in your head, you can write this as prove f of x equals ln x on x has a max at some number 1 on e. Meaning that this graph goes up to a maximum of 1 on e, but doesn't go above it, and there is no other maximum. So really it's asking us to find the max of this graph. Ideally we find where it occurs, but show that it'll be the only max. So we're going to differentiate this. U equals ln x, v equals x, u dash is 1 on x, v dash is 1. Therefore, f dash x is u dash v minus on well, that's right, I've actually got the funny board. What this is saying is this will equal to 0 when this is equal to 0 at the top. So therefore, 1 take ln x must equal to 0. That's saying 1 equals ln x. ln of what? ln of something gives us 1. Well, you can do the default of raise both sides to the base of e. So e to the 1 equals e to the ln x. E to the 1 equals x. Which kind of makes sense because e to the power of what gets us 1? Well, that's just e. Scratch that last sentence. The answer is x equals e. So that's told us this point here, x is e. We haven't actually proved it's a maximum yet, so let's do that. If x is e, this is an f dash x function, our first derivative. We're looking for here and here. We're told it's a max, but we can double check it. If this is less than e, like e to the power of a half, if we sub in e to the power of a half, 1 take e to the power of half, e to the power of half will give us a half. 1 take a half is negative, is positive. This denominator here is always positive, so that'll be positive. If we take e squared down here, 1 take ln of e squared, ln of e squared is 2, 1 take 2 is negative, it'll be here. That implies there is a max at x equals e. Now we need to find the value of that max. We want f of e. F of e is ln of e on e. ln of e is 1 on e, is what we're asked to prove. This function is less than or equal to this for all of x. There is only one turning point, it's a maximum. It does touch 1 on e, but it doesn't go beyond it. And battery's dying. Sorry, I didn't get time to do it all, but yeah, battery's dead. We need a better camera.